A star 650 light-years away has been hiding a secret for 10 million years. And in the last 12 months, we've caught it twice. First, a companion star buried inside Betelgeuse's atmosphere, confirmed by direct imaging in July 2025. Then, in January 2026, Hubble detected that companion's wake, a trail of dense gas carving through the red supergiant's outer layers. Betelgeuse isn't just dimming again, it's being disrupted from the inside, and that changes the countdown to the most spectacular explosion humanity will ever witness. For most of human history, Betelgeuse was just the red star in Orion's shoulder. Ancient astronomers catalogued it, Polynesian navigators steered by it. The Kokatha people of Australia tracked its brightness variations long before Western scientists understood what a variable star even was. But Betelgeuse was never constant. It's a red supergiant, a star so enormous that if you dropped it into the center of our solar system, its outer layers would swallow Mercury, Venus, Earth, Mars, and the asteroid belt, pushing all the way out to Jupiter's orbit. Its radius is roughly 800 times that of the Sun. Its mass, somewhere between 15 and 20 solar masses, is so concentrated in its core that the outer layers are barely being held on by gravity at all. The star is dying, and it has been dying for a very, very long time. In October 2019, something happened that made the entire astronomical community hold its breath. Betelgeuse started to fade, not subtly. Dramatically, over 4 months, its brightness plummeted from magnitude 0.5 among the 10 brightest stars in the night sky to magnitude 1.7, a threefold drop. If you looked up at Orion in February 2020, you could see it with your naked eye. The red shoulder of the hunter was visibly dimmer. The media went into overdrive. Headlines screamed supernova. Social media lit up. For a brief, strange moment, a red supergiant star became a global obsession. And then, just as suddenly, it brightened again. By April 2020, it was back to normal. False alarm. But what actually happened was far more interesting. Using Hubble observations, astronomers reconstructed the sequence. Betelgeuse had experienced a surface mass ejection, a violent expulsion of stellar material from its outer layers. As that gas cooled, it condensed into a massive dust veil that drifted into our line of sight and blocked a significant fraction of the star's light. The great dimming grabbed headlines, but it obscured a deeper puzzle. Betelgeuse pulses on a roughly 400-day cycle. The star itself expanding and contracting. Normal for a dying supergiant. But there's a second, much longer cycle. Every 6 years, Betelgeuse undergoes a larger, slower brightness variation, the long secondary period. For decades, nobody could explain it. The 400-day pulse was the star's internal physics. The 6-year cycle was something else entirely. Then researchers proposed an idea that sounds almost too elegant to be true. What if Betelgeuse had a companion? A smaller star orbiting so close that it actually passed through the supergiant's extended atmosphere, stirring up gas every 6 years. The Betelbuddy hypothesis was born, but for years it remained exactly that, a hypothesis. The companion was predicted, never seen. Betelgeuse's glare was too overwhelming. On July 21, 2025, the hypothesis became a photograph. Using the Alopeke instrument, Hawaiian for fox, on the 8.1-meter Gemini North telescope in Hawaii, a team led by Steve Howell at NASA Ames captured something extraordinary. A speckle image, a tiny point of blue-white light, separated from Betelgeuse by just 52 milliarc-seconds, the equivalent of spotting a grain of sand next to a floodlight from miles away. The companion was real, exactly where the models predicted. They named it Siwarha, Arabic for her bracelet, a reference to Betelgeuse's own name, Yad al-Jawza, the hand of the giant. The companion is the bracelet on the giant's hand. Siwarha is a pre-main sequence star. It hasn't even started burning hydrogen yet. While Betelgeuse raced through its fuel and ballooned into a red supergiant in just 10 million years, Siwarha, only 1.5 solar masses, is still in its cosmic adolescence. Both formed from the same nebula. Mass determined destiny, and yet Siwarha is doomed. Orbiting deep inside Betelgeuse's extended atmosphere, it's slowly spiraling inward. In about 10,000 years, Betelgeuse will cannibalize it. The bracelet will fall into the giant's hand. Confirming Siwarha was a triumph, but it was only half the story. In January 2026, just 6 months later, Hubble delivered the next breakthrough. Astronomers at the Center for Astrophysics at Harvard and Smithsonian had been tracking subtle changes in Betelgeuse's light across nearly 8 years. What they found was a wake. As Siwarha orbits through the supergiant's vast, diffuse outer atmosphere, it's not moving through empty space. It plows through dense gas like a ship through water, leaving a trail of compressed material behind it. Hubble's spectral data traced this wake even when the companion itself was invisible. This is the smoking gun. The mysterious 6-year brightness cycle isn't the star pulsing. It's Siwarha stirring the pot with every orbit. The long secondary period that resisted explanation for decades is the orbital period of a companion nobody could see until 2025. Everything we thought we knew about Betelgeuse, the dimming, the pulsing, the instability, was being rewritten by one faint companion star. Subscribe now, this is only the beginning. While scientists processed these discoveries, Betelgeuse dimmed again in 2024. Not as dramatic as 2019, but enough to reignite supernova speculation, and now the context was different. We knew the pattern wasn't random stellar instability. It was the predictable consequence of a binary interaction. But the star had behaved strangely in between. An unusual brightness surge in April 2023, another dip shortly after. This pattern, brighten dim, in under 24 months was unprecedented in modern observations. Some astronomers began asking the uncomfortable question, what if Betelgeuse is entering its terminal phase? A June 2023 study analyzing pulsation periods concluded the star is in late-stage core carbon burning. That phase for a star this massive lasts roughly 1,000 years. If Betelgeuse is near the end, the supernova isn't 100,000 years away. It could be tens of years away. So when will it actually explode? The honest answer, nobody knows. The range spans it may have already happened to sometime in the next 100,000 years. The critical fusion, carbon, neon, oxygen, silicon, happens deep in the core, buried under hundreds of millions of kilometers of plasma. We cannot see it, but the surface is telling us something is accelerating. 2019 to 2020, the Great Dimming. 2023, a brightness surge. 2024, another dimming. 2025, companion confirmed. 2026, companion's wake detected. All of this compressed into 7 years. When carbon burning ends, the cascade begins. Neon fusion, perhaps a year. Oxygen, 6 months. Silicon, a single day. Then the core becomes pure iron. The end of the line. Iron cannot fuse to produce energy. The core collapses in less than a second. Supernova. If Betelgeuse is truly in late-stage carbon burning, that cascade could begin in our lifetimes. Or it could have already happened. Betelgeuse is 650 light-years away. If it exploded 649 years ago, the light arrives next year. When we see the supernova, we're watching an event that already happened centuries before. When the light reaches us, a Type 2 core collapse event. The core collapses into a neutron star, releasing a shockwave that tears the star apart. More energy in seconds than our sun will produce in 10 billion years. From Earth, it will be the brightest celestial event in recorded human history. Brighter than the full moon, casting shadows at night, visible in broad daylight for weeks. The supernova of 1054, which created the Crab Nebula, was visible during the day for 23 days. Betelgeuse is much closer. Peak luminosity lasts about 2 weeks, then fades into an expanding supernova remnant. The core becomes either a pulsar, a neutron star 20 kilometers wide, spinning hundreds of times per second, or a black hole. We are completely safe. 650 light-years is far enough. The gamma rays and X-rays dissipate harmlessly. We get the light show, the best seat in the galaxy, and Siwarha, vaporized by the shockwave or blasted into interstellar space as a runaway star, a cosmic orphan at hundreds of kilometers per second. The most spectacular explosion in human history could have already begun, its light racing toward us across the void. Hit the bell. Don't miss what comes next. A galactic supernova hasn't been observed with modern instruments. The last confirmed Milky Way supernova visible to the naked eye was Kepler's supernova in 1604, before the telescope was even invented. Before that, Tycho's in 1572. And the great supernova of 1054, which created the Crab Nebula, was recorded by Chinese, Japanese, and Arab astronomers, and possibly painted on a canyon wall at Chaco Canyon by the ancestral Puebloans. Since 1604, the Milky Way has been quiet. We've observed thousands of supernovae in other galaxies, distant pinpricks of light, but we have never watched one in our own galactic neighborhood with neutrino detectors, gravitational wave observatories, and space telescopes. When Betelgeuse explodes, neutrino detectors like IceCube in Antarctica and Super Kamiokande in Japan will catch the first signal, a burst of neutrinos escaping the collapsing core hours before visible light. That burst is the warning bell. Every telescope on Earth and in orbit will swing toward Orion. It will be the single most studied astronomical event in human history, answering questions we've been asking for centuries about how massive stars die and how the universe forges elements. Every atom of iron in your blood, every atom of gold in the Earth's crust, forged in supernova explosions. You are stardust. That's not a metaphor, that's chemistry. When Betelgeuse explodes, it will scatter carbon, oxygen, iron, and heavier elements across hundreds of light years. Those atoms will drift through interstellar space for millions of years, eventually becoming part of new stars, new planets, perhaps new life. Betelgeuse is ours, the nearest red supergiant, the most watched star in human history, and one day, possibly very soon, it will give us a front-row seat to the process that makes planets, life, and everything we know possible. Keep looking up. The countdown has already started.